Okay, I think we'll get started. We're down to a hardcore crew of students. So if anybody has questions, it's a small enough group, please feel free to just jump on the audio and speak up. This is lesson 7, and what we're going to focus on tonight is the internet and the web for the first half of the class. And the second half, we will take the app that we started building last week and build on it, enhance it. In particular, since the theme here is the web, we're going to put a web user interface on top of it. I'm recording. Feel free to mute things if you don't want to be on the video. But as I said, jump on the audio if you're okay with it, if you have any questions. The notebook is mco.fyi/i7. And I will jump right into it. So as I said, the first half, I'm going to do kind of a review of the internet and the web. And I have a talk that I've given in the past, so I'm going to like jump out to a slideshow for this. So if you click on that, how the web works or how the internet works link, it will take you to these slides and you can kind of work along with me. The reason I like doing it this way is because I feel like we all use and depend on the web every day. And some of us know a lot about how it works, but a lot of times we don't know the inside workings very well. And I think it's really helpful to have just a bit of a perspective on what's sort of going on underneath the covers, because I think knowing that helps you a lot with other programming tasks, especially network-based programming. So you'll hear typically with networking, there's a whole nother jargon. You'll hear HTML, HTTP, URL, etc. And it sometimes can just feel like alphabet soup. And so I want to walk you through what these things are and how they function. And the way I'd like to do it, and I apologize if there are web experts on the call here or internet experts, but I wanted to just kind of get us on the same page before I launch into programming on the web. So we'll walk through a very simple example. You're sitting in a browser and you enter a URL and what actually happens to make that thing work. First of all, the way you identify a website or a destination on the web is called a URL, which is short for Uniform Resource Locator. And you've all seen these, you're typing them all the time. There's an example here. And really this has 3 components to it. One is the protocol, that's the first part. The second part is the server, and the third part is the path to the resource. And they work together. Essentially, the protocol is how do you want to talk to this destination? So you'll see HTTP or HTTPS being the secure analog. That's the how do I get there. The server is the where. Where is the thing I want to access? And the path is the what. What is it on that server that I want to get access to? So you combine the how, the where, and the what, and it's a full specification for getting your hands on something. Now, this name for the where, mco.dev is this example, but it could be any what we call domain name. Your computer doesn't actually know how to reach that name directly. What it has to do is translate it into a number. And it turns out every computer on the internet has a unique number. We call it an IP address, Internet Protocol address. And so what the computer does when you enter that name is it converts it to its underlying address. And the way I like to think about it is a little bit like when you call someone, you don't just type their name. Well, you do if you're using like a smartphone with contacts. But if you kind of go back into the dark ages when we had phone books, you would actually open a book and look up someone's phone number and then call that number. And that's kind of what DNS is. It's a name to number mapping, but it's much more automated. Your browser knows how to look it up and just figure out the answer and just start using it. If you're curious as to what your address is, you can go to this link, whatismyipaddress.com, and it will tell you your actual number associated with the computer you're using right now. I don't want notifications. And it'll even tell you where it thinks you are. Obviously, it figured out I'm in London. In fact, you can even say, right into the Google search, I think you can say something like my IP address. It'll tell you right at the top. So That's what DNS is. So you specify the how, the where, and the what, and the browser turns the where into a magic number that it knows how to reach out to. And then the how, the HTTP or the HTTPS or any other ones, is really just a set of rules for communicating by computer to computer. And the analog here is the way we use telephones, right? When you use a telephone, you normally have a very set pattern that you follow. It's sort of an etiquette. You say hello, the person says, is so-and-so there? And so we follow these conventions, these rules. And that's all a protocol is, except it's much more precise and much more formal. When a computer is talking to another computer, it follows a very strict set of guidelines to initiate a conversation. HTTP is one set of rules, HTTPS is another, FTP is another. There are a bunch of these different protocols. And when the browser sees you say HTTP, it says, okay, that's the way I'm supposed to talk to the address that I'm supposed to connect to. And this communication is very layered. There's a bunch of different protocols running one on top of another. The lowest level is the network, and that's like the physical connection, the hardware, the cables, etc. The IP layer is breaking the data up into chunks and passing those chunks around without regard to the order or whether some get dropped or lost. It just does its best effort. And then TCP is the one that sort of tries to make sense of all that. So it's worried about making sure that if there was a dropped packet, it gets resent, making sure that packets that arrive out of order get assembled back in the intended order. So TCP sort of like bringing order out of this lower level IP network. And the thing that's cool is IP can send the packets any way it wants, and every given packet can take a different route. And TCP is at either end, making sure it all comes to the consumer in a coherent stream of information. And then HTTP is a protocol on top of TCP for requesting and responding to web resource requests. So essentially your browser is an HTTP client, and the web server that you're connecting to is an HTTP server. And they make a connection over their hardware, they make this IP, they transfer these IP packets, they establish a TCP connection, and then they set up an HTTP connection to actually make these higher level requests, like give me this image or give me this web page or whatever. The lower three layers are collectively known as TCP IP. So what does an actual request look like? It typically looks like get and then a resource name, which is equivalent to saying, give me something. Here's what I want. And if you remember back to the three parts of the address, that's the what. So you can read much more about all these things. For example, there's an official document that tells you all the details about HTTP. And you can see one of the co-authors is Tim Berners-Lee, who was the original inventor of the web. So these are actually fairly readable documents. They're not, you're not going to have a great time. It's not like nighttime reading, but if you're ever curious, you can look at these documents and get a lot out of them, understand what was going on. I'm going to share, I don't do this a lot, but I want to just share this short video because it's really enlightening, I think, as to what's going on inside the internet. And it's also the guy who's telling the story is one of the early inventors of the internet named Vint Cerf. So it's just about a minute. Let me play it for you. Let me know in the comments if you can't hear it or anything.
And gets transferred from one computer to another is pretty interesting. It need not follow a fixed path. In fact, your path may change in the midst of a computer-to-computer conversation. Information on the internet goes from one computer to another in what we call a packet of information. And a packet travels one place to another on the internet, a lot like how you might get from one place to another in a car. Depending on traffic congestion or road conditions, you might choose or be forced to take a different route to get to the same place each time you travel. And just as you can transport all sorts of stuff inside a car, many kinds of digital information can be sent with IP packets, but there are some limits. What if, for example, you need to move a space shuttle from where it was built to where it will be launched? The shuttle won't fit in one truck, so it needs to be broken down into pieces, transported using a fleet of trucks. They could all take different routes and might get to the destination at different times. But once all the pieces are there, you can reassemble the pieces into the complete shuttle and it will be ready for launch. On the internet, the details work similarly. If you have a very large image that you want to send to a friend or upload to a website, that image might be made up of tens of billions of bits or ones and zeros, too many to send along in one packet. Since it's data on the computer sending the image can quickly break it into hundreds or even thousands of smaller parts called packets. Unlike cars or trucks, these packets don't have drivers and they don't choose their route. Each packet has the internet address of where it came from and where it's going. Special computers on the internet called routers act like traffic managers to keep the packets moving through the networks smoothly. If one route is congested, individual packets may travel different routes through the internet, and they may arrive at the destination at slightly different times or even out of order.
So that was a little longer than a minute, but I hope that was interesting. What I like about that is that his example with the space shuttle is really a great idea around what I was talking about how the information gets fragmented, and the IP layer is just worrying about, let me do my best to get every packet where it needs to go over whatever route I need to get it in. And the TCP layer that's really making sense of everything is the equivalent of the two ends on the one side breaking down the shuttle and on the other side reassembling it. That's really TCP's job. Okay, let's go back to our slides. Sorry, I was there. Okay, so you give your browser a what, a how, a where, and a what, and it goes and gets it. And what comes back has to be formatted in some way that the browser understands how to present it to you. And the language of the web, not for the transportation or communication of content, but for the presentation of content, is called HTML, which is hypertext markup language. And this was invented along with the web by Tim Berners-Lee and many other people. But the idea here is it's a way of simply defining the layout of a page so that the browser, when it receives this content, knows how to present it to you. So here's an example of some content, some HTML content. The H1, you'll see these tags. So you see like the H1 here between angle brackets is a special type of tag. And whenever you have a tag like this, you'll see a terminal tag or an ending tag with the same name but a slash preceding it. So H1 is opening the tag and /H1 is ending it. H1 means header level 1. So that's telling your browser, present this text in a bigger, more prominent way than other regular text. The IMG tag is an image tag. So this says present an image next, right under the here's a picture text. The src equals, that's source equals, that's a URL to where the browser should get the image from. Height equals 500 is a little bit about how big I want the picture to appear. P is a paragraph tag, so it tells the browser set this off by itself and consider it one unit. And then A is the last one down here at the bottom is what we call hyperlink. This is what you see every day whenever you go to a website and you see the little highlighted text. The way we specify a link in HTML is we have an open A tag, and we put a couple of parameters on that tag. So here we say href equals, and the string inside the double quotes here is where the browser should take you to when you click on this link. And then we have a bit of text here, visit my blog. That's what the browser should present to the user associated with this link. And then the /a just terminates the tag. So this fully describes a link as the browser should present it to the user. Jump in if you have any questions on any of this. I hope I'm not going too slow and everybody knows everything I'm talking about here. And if that's true, just give me a comment saying speed up, Mark. So you do this, you visit this URL, the information comes down to the browser, and you can see from this panel here that it first got the miko.html file, and then included in that was miko.jpg, and then some other things that I didn't even request. But let me actually show an example of this. So mko.dev/miko.html. Okay, so this is exactly the HTML I just showed you. And in fact, you can right click in Chrome and say view page source, and you get another window with the source of the, and this is just the browser saying, this is what I got when I requested the thing you asked for. I interpreted it and rendered it nicely in that other tab, but this is what I actually got from the server you requested. And as you can see, it looks exactly like what I showed you in my slides. Wow, that's a close up. The other cool thing is you can open up something called Chrome DevTools, which is a developer tools sort of environment. Let me see if I can slide this over a little bit. And you can see a lot of different things about what the browser is doing. For example, if I click on this network tab and I reload, I can see that it's getting these different parts. The first thing it got was obviously miko.html, then it got miko.jpg. So that's the actual picture. And you can actually see all the details. You can see, for example, request method get. That's HTML. Remember I said it's get, and then it identifies a resource. So it said to the server, get me the miko.jpg thing. The status code was 200. That means the server responded with that protocol element 200, which in HTML means okay. It's a weird number to mean okay, but it does. And you get all this other information like what date the image was sent, how many bytes it was, all this kind of additional stuff here. But that's what's happening under the seams. And Chrome does something interesting here. It gives you kind of a step-by-step picture of what happened when you did this request. I'm not sure why I got this full one. I think that was the cache coming back. But then it got the regular document from the web, from the network. And you can see it first just rendered this part, and then it got the rest. It got the, let's see, did it get the text below it? Can't tell. It got the picture, and then it eventually was able to render the whole thing. I'm not sure why it's cutting off here. But anyway, this is a fun thing to do. And there's also things you can do with performance checking too. You can sort of test how fast things are coming down the wire, where all the time's going if your website is slow. Lots of good things you can do in here. But yeah, mainly I just wanted to show you sort of what's happening under the covers. So if I jump back to these slides, I want to just quickly summarize the sequence that's happening. So you specify a URL, your browser takes that URL and it divides it into pieces, the protocol, the server, and the path or the resource name. It converts the server name to an IP address. It connects to the server's IP address using the TCP protocol and starts an HTTP conversation. Once everything's all set up and the server's kind of like, okay, I'm ready, what do you want? The browser sends an HTTP GET to request the file that you want that was in the URL. TCP makes sure that the HTTP request gets there and is assembled as it should be, and so on. The browser, or rather the server, looks and says miko.html, I actually happen to have that file. If it doesn't, it will send an HTTP404, and that's where 404 comes from. That's the HTTP code for file not found. But assuming it has it, it says, okay, yep, I have miko.html. I'm sending it back. Here's the file, and here's a HTTP 200 to say all is good on my end. The browser receives that file and it renders it. As part of rendering it, it bumps into this image tag with a need for fetching an image. So you'll see this happen a lot. One page will link to many other pages and sometimes fetch many other pages. And so if you actually go to a site like the New York Times and you turn on the network tab, let me clear this. And let's just go straight to the New York Times right there. You see how much is going on here. It's fetching tons of stuff. Some things are failing. You don't even know it. Hopefully not something you need or care about, but all these ads and all this content, there's just a lot happening. And you can actually click on these things and find out what they're doing. But and you can also do what I did before with view page source, and you can see, you can actually look at the HTML source code for the New York Times. Now they sort of zip it up in a very cryptic form. It's actually more for efficiency than protecting the information, but as a result, you really can't read this. It's like gibberish. There is a way to uncompress this though and take a look at it. So that is one of the cool things about the web, is if your browser can see it, you can see it. And you can sort of reverse engineer things if you want to. There's a great site called glitch.com. And if you're interested in this kind of stuff, it has some really nice tutorials about the web and web programming. You can learn more about things like HTML and CSS and JavaScript. Those are the three big components to web programming. Have a bunch of demos here, but I actually think I'm gonna gloss over these for the sake of time. If we have time at the end, I can come back to one or two of these. One thing to note is you can sort of fake out being a browser by just typing the right commands in text to a web server, and it will think you're a browser. It's actually simpler than it might sound. You won't. You'll get these cryptic replies, but you will see the HTTP. In fact, here's a screen capture of it. So this telnet command lets me make a connection, and whatever I type on the keyboard gets sent to the server. So I say telnet example.com 80. That's a port. I didn't really explain what a port was, but it's probably not too critical at this point. It's just like a channel within that server destination. And by default, I didn't have to specify that because HTTP by default is port 80. So anyway, I say connect to this host on port 80, and you see automatically it says trying 93.184.216.34. That's because this command did the DNS lookup for me. It connected and said, go ahead and type stuff in. So this get, that's me. I typed get /HTTP 1.1. So I'm saying get me the /, that's whatever's at the top level of the file tree. And I want to speak this version of HTTP 1.1. And by the way, my name is example, or the name that I think you are is example.com. So if you're not that host, let's drop this right away. And then I get this response 200 OK, which is basically the server saying, yep, I got it. I'll give you the document. Gives me a bunch of other information, and then the actual HTML is right here. So you can sort of fake out, make believe you're a browser, and the server has no idea. Likewise, you can make your own web server. If somebody told you, oh, I wrote my own web server this weekend, you might be impressed, but it's actually not that hard. This is an entire Python program that serves web content. It's not the most sophisticated in the world or complete, but it actually is a working web server. And I'll show you one more example of that interactively in a minute. This is a cool site to see how the internet actually moves packets around the world. So you can say, get a trace route from, let's see, from Nuremberg. I don't know why I'm starting with that, but I'll just take that to Afghanistan. And it actually gives you sort of an animation of how it gets there. I don't know why it's going into the US. I think I must have given it something. Yeah, it ended up going to Houston. I thought I picked Afghanistan, but anyway, Nuremberg to Houston, you can see the packets So these are those routes that Vint Cerf was talking about, where the IP packets are traversing. It's going from Nuremberg to Frankfurt to Paris. From Paris, it takes the one of the undersea cables to someplace called Ashburn. I have no idea where that is. It looks like it's the northeast. To Atlanta, to Dallas, to Houston. So that's a pretty cool thing to look at. Yeah, I'm not going to go through much more of this, but feel free to look over those slides. And I will show you this demonstration web server because I think it's kind of cool. So I'm using a site called repl.it, repl.it, which is a nice little tool for building kind of snippets of code and sharing them and running them and testing them. So I built a little Python app here, and it's using something called Flask. And Flask is a library that makes it easy to build web servers. So if you look at this, it's like basically 10 lines of code maybe, and I've got a working web server. All I have to do is say app equals Flask, and don't worry about the underscore name. That could pretty much be anything. But the key here is I'm instantiating an object, a Flask object. Just like I create a list, a dictionary, a number in Python, I'm creating something called a Flask. And that's defined by this module I'm including from. And then I say I want to assign to the route /, meaning if an HTTP request comes in for /, I want to run this function, say hello. Now what say hello does is it sees if there was a name specified in the URL. And you can kind of ignore that for now. Just assume there wasn't. And if there's no name specified, it'll set this name to world. That's sort of the fallback if there's no name specified. Then it uses this random package, which I import here, to generate a random color. And I store that in this variable random color. I convert it to a different representation that the browser wants to see it in called hexadecimal. And I store that in a new variable, hex color. Nothing magic about it. It's just that the browser, when it processes HTML, it wants those numbers in a special type of format. So I do that right there. And then I use something called CSS, which is the one other component of the web for setting up the look of things, called styling. I set up this style variable to say background color, it should be set to this color. Now this is a random color. So basically I'm saying I want to present something with a random background color. And then finally I generate some HTML here, and I'm just using strings. I'm hard coding these values. The actual content I want to generate is an H1. Remember we saw an H1, that's a heading. And I just want it to say, using my background color here, that's what the style equals. I just want it to say hello and then the value of name. And since name is defaulting to world, it'll say hello world by default. So this is really nothing more than a function definition. It's not running anything yet. This is where everything starts. I say app run, and app is the variable that's pointing to this Flask object. I say app.run, so it's a method on that object. I tell it what host I want it to be pointing to, and that's sort of like the local host. That 0.0.0.0 means run as if you're just answering local connections from anybody who's running on the same computer. The port 8080, that's similar to what I said earlier, that HTTP is usually port 80, but I'm just using a different one to stay away from the real HTTP traffic. And these two are not too important to worry about. But let me run this and just show you what it looks like. It's installing some dependencies. And it sees this as a browser-based app. So it brings up a little integrated browser window here. And as expected, it says hello world with a random color. If I keep reloading, I get the same string, but a different random color each time. Now, I had mentioned also that I could pass some information to it, and that's this line right here, request.args.get. Now, we know how to pass arguments in Python. We put those arguments in the function call. How do you pass arguments on the web? Well, it's done with these funny URL syntax. Actually, let me open up a new tab. Make sure that's working. Yeah. Okay. So at the end of the URL, I can say question mark name equals value. And if I have more of these, I can say ampersand name2 equals value2. You've seen these before, I'm sure. This is how you pass arguments or requests to a web server. So the thing that I'm looking for is an argument or a parameter called name. So I have to use that syntax. And I'm going to say name equals Jordan. And what it should say is instead of hello world, it says hello Jordan. And so now you're seeing how you can sort of pass argument just the way you can pass function calls. You can pass arguments to a web server. Okay, so we built with like 10 lines of Python, we built a functioning web server. It doesn't do anything terribly impressive, but hopefully that just demystifies a little bit of what's happening when you're using the web. Okay, so how are we doing on time? I have a little more time to go. I'm going to pick up with where we left off last week. So if you remember, we built this newscatcher app, and it was designed to be fully automated, and you give it some list of sites you want to pull and some topics you're interested in, and then you run this program and it goes off and gathers the new articles for you. And so this is the code we had. First thing we have to do is install the
Mark,
module. Yep.
Can you please increase the font size?
Oh, yes. Thank you. The first thing we want to do is install the library. I think I just did it, but do it again for good measure. And if you're following along, feel free to run this code with me and make sure it works for you. Now that I've installed this module, I need to import it so that my Python code can do something with it. So I'm going to say from newscatcher, import these two functions, newscatcher with a capital N and describe URL. And then I'm defining these functions that are using this newscatcher library. And if you were here last week, you've seen these functions already, but let me just quickly review them. Get new articles takes a site and a topic. Now the site is a URL, and the topic is sort of a symbolic topic for what kind of content you're interested in, like business, politics, tech, that kind of thing. So you pass this newscatcher the site and the topic, and then you say get news, nc.getnews, and you get the results in this. You store the results wherever you want. I happen to be putting them in this variable named results. I could just as easily call this articles, as long as I'm then consistent and use that same name here. And I have to do it here and here. So what's happening here? This newscatcher object is kind of being like a mini web browser. It's going off and doing all the things we talked about earlier. It's making a connection over TCP. It's using HTTP to send a GET request. All that stuff's happening under the seams, and you don't have to worry about it. So this is why you use other people's code and use that import a lot, because you don't want to reinvent the wheel. This is really taking care of a lot of things for you. So this get new articles returns a list of articles, and then you can iterate through those and find each article, do something interesting with each article. Get news is sort of like the generalization of get new articles. It's basically iterate through get new articles for a number of sites and a number of topics. And you can see that structure very clearly here. For IN sites means let's go one at a time through the sites. First, let's make a list of the topics that site knows about. Let's not waste our time searching for topics that site doesn't even care about. And then within each site, let's iterate through the topics. First thing we do, if J is not in the topic list, forget it. Don't waste your time. We do a continue, which jumps back up to the top of the for J in topics loop. Assuming that J is in the topic list, we say get new articles for this site and this topic, which is just calling this function I just went through last. It gets the result in articles, and then it appends that list to kind of an ever-increasing list that it starts out empty, and each time through the outer loop, it's adding onto that. Actually, through the inner loop, it's adding on to that complete list of all articles, and then it returns all articles. And display is just a utility function to do kind of a pretty printing of all the articles it finds. So we'll test this by calling get news, and now this is the aggregate one, so I can send it a list of sites and a list of topics. And just to make sure it's working right, I'm going to go with more than one of each. So I send it two sites and 2 topics. And I'm just keeping, I could use variables, but I'm just putting it in line here to try it out. Whatever comes back should be a list of articles. I store it in this variable articles, and then I call this display function to print it out. So hopefully that works for you as well. This print statement is printing an ever-increasing number so that I can say, you know, this is article number 15 and have them uniquely identified to people who might be looking at this report. I get the title, and then I get the link. And as you can see, these links are all coming from the New York Times, but I'm hoping to see what was my second. The Guardian was my second news source. So if I scroll down, hopefully I get, yeah, there's some Guardian articles. And if you click on Samsung Galaxy Bookflex review, if you click on the link to the right, yep, it's what I was hoping it would be. So looks like this is working. Obviously, you'd want to test it a little more thoroughly, but this looks good. And this is where we left off at our last class. So I'm just going to delete the output here. And there are a few things I want to add now. One is I want to make the configuration data persistent. What does that mean? That means that I want my program to have a memory. I want it to remember which sites I had it working on every time it starts up. I don't want to have to tell it, oh, by the way, the New York Times, I like the Guardian, I like this, I like that. I want it to remember. And the way to do that is to read and write files. So if you remember from last week, we also covered the Python way to read and write files. And this is how we make information permanent, because if we just leave it in variables, they disappear as soon as the program stops running. So in order to make our configuration data sort of stick around between instances of our program, we're going to define some variables, some what we call global variables, because they're defined outside of any particular function. The first is config file. So that's the name of the file where I want to store my configuration information. And I've decided to call this program my newsfeed. And I'm using this CFG extension. I could have called it .txt or anything else, but it's going to be a simple text file where I'm going to keep configuration data. I've got this variable set to a dictionary, which is kind of like a basic configuration set of configuration settings. So this dictionary has 3 keys: sites, topics, and scene. And this is, I just sort of designed this because it felt natural to me. You can define this config information any way you want. I could have had a sites list, you know, sites equals a list of things and topics equals a list of things, but I liked kind of consolidating it all into one structure. Now this CFG init is not actually the config data. The config data is right here, the lowercase CFG data, which I initially set to the uppercase CFG init. So what's going on here with the uppercase and the lowercase? Typically in Python programs, uppercase names mean constants. In other words, this data will never change. You set it to this init, for example, I set it to this kind of basic setting of my configuration values. I'm never going to change the initial set of configuration data. But I'm actually going to, at runtime, use this variable lowercase CFG data to refer to the actual current settings. And I'm simply initializing it to the init value so that it has like a base state. But it's going to, over time, change and deviate from that initial setting. I can just print these out to make sure they look reasonable. CFG init. And on a separate line, I'll do a print of CFG data. And you can see the Python print statement kind of wraps that up into one line, but you can see it's pretty much the same. By the way, sites is obviously the list of sites. Topic is the list of topics. Scene is something that I'm going to deal with later, but it's going to keep track of which articles I've seen so that I don't keep retrieving the same articles over and over again. But for now, it's just a placeholder. Okay, so I've got this structure for representing my configuration for my program. And now I need a way to make it permanent, to write it to disk and to read it from disk. When do I want to write it? Anytime it changes so that it's recorded. When do I want to read it? When the program starts up so that it goes and fetches whatever the latest settings are. So the way I'm going to do this is to have two functions, save config and load config, which is basically can be read as write and read, respectively. I'm using a package called JSON. JSON is nothing more than a way of taking data in a programming language and converting it to a format that's readable externally in a disk file. So you can think of it as just representing your data in a convenient and human readable way. And I can give examples of it and stuff, but for now, just think of it as like turning it into a format that works really well when we store it on a disk. So save config basically says, I'm taking a file and some data. If there's no data there, then I'm going to, if you didn't pass me data, then I'm going to use the default that we're keeping in the global environment, CFG data. And the file, I'm going to open it using this with statement, and I'm going to do f.write. So I'm writing the file, overwriting it with this JSON-ified version of the data. So this gives me the ability to just call save config like this. I can say save config, and if I'm happy with the default file and the default data, I can just call it like that. And whatever my current data is, it'll go to this file. If I want to override some of those values, I could say save it to, my test file, CFG, and I could even give it some different data. But typically, I'll just take the default values there. And I'm not sure I even showed you this syntax here where you can put an equal sign after a parameter, and that tells Python this is the default in case the user doesn't pass that value. The load config is sort of the inverse. It's really just the opposite. It takes a file. It doesn't take data because it's getting the data, so it's going to return the data. So it just takes a file, and by default, it'll use the default file. And what does it do with that file? It says with open for read. By the way, the save data opens for write. This one opens for read. And it sets the file object pointer into this variable f. And then the body of this with block is just simply load do a read, an f read, parse the JSON, and return a string, which is the internal, actually return a dictionary, I guess it'll be, which somebody who is calling this load config could then use it to use the config data in the program. So just like I could call save config that way, if I wanted to use load config, I would say load config. I could take the default file, but I have to, what's going to come back is the data it's loading. So I have to put that somewhere. So I could say config data equals load config like this. That's how I would use it. We're going to use these in a minute. But anyway, it's a pretty short function, 3 and 4 lines. And this gives me the power to save my configuration data, to save this data structure here, and to load it off disk. This reset is just an extra utility function. It resets the config data to be the initial version and saves it. So if I've done some work and I've got the configuration in a certain state and I kind of want to reset things back to where they started, I can call this reset function. It's more for me than anything else, just for testing, but it's handy to have. Okay. Whenever I write little functions like this, I like to write test code. We call these unit tests. And these are small functions that just verify that the function you just wrote is doing what you think it's doing. So I'm doing that now. I'm going to test the load and the save functions because I don't know if they really work. They seem right to me, but I always seem to make mistakes here and there. So I've got this test data variable, and I'm setting it to a config, like dummy config value. I'm using site names that aren't URLs. I'm using topics that don't make any sense. This scene thing, I'm just filling up with some garbage. I just wanted to have a data structure that fits the specification. I don't care if the values actually make sense or not. I call save config, and I'll take the default file, and I'm going to tell it to take the data from this test data one structure. At the end of that, the file should be written. So I can even stop the test right there and see if that worked as I expected. So let me run this. And then down here, I'll add a code cell. And there's a way to say what files are out there, this ls thing. And there's my newsfeed.txt. And I can say, show me what's in my newsfeed. Actually, it's CFG that I want to look at. And there you see it's basically the stuff I just told the save config function to save, the sites, the topic, and these dummy key values and values for scene. So that seems to be working. Now what we're going to do is after we do the save config, we're going to call load config, and we're going to take the reply from that, the return value, stored in test data 2. And then we're going to say if test data 2 equals test data 1, if the stuff we got back after we wrote it and read it back in, which is stored right in this variable, if that matches this mess, then we're going to print test passed. Otherwise, we're going to print test failed. So from that, and nicely, we find that the test passed. So it's really writing our stuff into a file and loading it back in. The last thing I did was reset config. And if you remember, that's just because I don't want all these weird things in my config. I actually wanted to go back to the default initialized values. And I can verify that that reset worked by just printing out the contents of the file. And you see the reset the data in memory and then called save config. And it's back to what I started with, which is the Guardian, one topic, and an empty scene dictionary. If you want to, we're past break, so I'm going to stop in just a second. But if you want to see how to read and write your data to Google Drive, which is quite straightforward from Colab, you can do it here. Just take a look at this code, and you can actually store your data instead of a file on this Colab server, which will disappear after a while. You can save it in Google Drive, and then it'll be there permanently on the web. Okay, I will stop there. We'll come back to adding a web user interface in 10 minutes. Let's regroup at 8:05, let's say. Okay, I am back, and probably have less than a half hour to go here, so we'll definitely finish up at 9:30, 8:30 here. Okay, so when we left off, we had added persistence, or at least the mechanism in order to make our configuration data persistent, so that when our program runs multiple times, it remembers where it, what its settings are. Any questions on any of that before I jump into the next section? Okay. In the next section, we're going to add a web user interface, and hopefully all that stuff we went through about what the web is and how it works will help inform some of this. So the first thing we're going to do is use that same library that I used when I showed you that interactive program called Flask. So we'll run this cell, which installs Flask. So that kind of fetches the Python code from the internet and pulls it into your local environment. That kind of gives you the potential to use Flask, but you still have to import it. And in the very next cell, we're importing Flask. We're also importing something special for Colab, which is something that gives us the ability to run a web server inside this notebook environment. In the real world, you wouldn't need to do that. This is an artifact of this notebook. But the rest of this code should look pretty familiar. In fact, it's pretty much, apart from this one extra step, the Colab thing, I think it's identical or almost identical. Well, at least the structure is the same to this app I showed you before. It's got the app route, the definition of the function, and then the app run to dispatch that function for any incoming requests. So let's run this and see what it does. Now it actually, this extra step starts something called a proxy, which makes it possible to, from outside Google, send a web browser into this notebook. That's kind of what it's doing for you. And so this link that it's printing out is the way in. It's basically the door into this web server that you're running inside the notebook. So if you click on that link, probably can't see it, it says hello world. And that's because my notebook function is returning hello world. Just to make sure we believe that actually worked. Now this sort of runs forever, right? Because the web server has to be there for any requests. So this cell is constantly running. I'll click stop because I want to change the code. Instead of saying hello world, I want to say hello students. And this is sort of just a way of proving to myself that this is really working the way I think it's working. So I have to run this cell now that I modified that function definition. And then I'll click on this link again, and now you can see it says hello students. If I stop this cell and effectively kill the web server, then if I refresh this window, I get an error because there's no, what's happening is the browser is changing this grotesque host name to an IP address, and it's making a connection to the IP address for port 80. And the server on the other side, the TCP module on the other side, is saying there's nobody listening for port 80. There's no HTTP server running right now. So the connection is refused. And that just sort of shows you that this server that we're running really is doing what we think it's doing. Okay, so that was just hard coding hello students, not a very impressive web server. What we'd like to do is run these fetches of articles of interest and display those in the web user interface. Now, in the previous version of this program, we just printed, we used this kind of a formatted print, these F strings, we call them, and we just printed out a nice table. And that looks fine. I mean, I think we can see one of those here. And that looks fine, but that's human syntax. That's a format that makes sense to our brains, but computers need, again, some rigid set of rules to understand how to process information. And the most useful form for a web server is, you guessed it, HTML. So what we want to do is kind of have a version of this display function, but instead of just printing out a nice human readable form, we want to print out an HTML version of this information. So let's go down to the next cell after that little test server. And we're going to write a function called display web. It's exactly like the display function. It takes a list of articles, but instead of just printing them with the print statement, it's going to put together a long string of HTML and return that to the caller. And the caller is going to be the web server. It's going to say, I got this request to present some articles based on these topics and these sites, gathers all the articles, and then it's going to call display web with the article responses. And the display web is going to return a nice HTML string that the server can then send to the client to render the list on the browser. So this display web is just assuming it's going to get a list of articles. All the plumbing and work to get those articles is done in those functions we already wrote. Display web takes the list of articles. It says if there's nothing on that list, then return this string, nothing new to show you. Otherwise, it goes through the list of articles and it builds up a few HTML constructs. The first one's called a table. And then for each article, it does a row, and then the elements in the row. It's basically the HTML version of the print. Okay, it's just a more formal and rigid syntax for making sure that this looks right on a browser screen. And one trick we're able to take advantage of is, whereas up here we had to print the title and the link separately, because the A tag, the HTML A tag, gives us the ability to combine those two things. If you remember, I said the syntax is href equals and then the URL, and then we put the actual text we want to show visible. We can combine those two and do these nice links where you'll see the title, and if you click on it, it'll take you to the URL, but you don't have to see the URL. That's not really that meaningful to you. You just want to know, how can I get there by clicking, and you can if we do this right. So yeah, all this does is take a list of articles and puts together an nice HTML table for the browser to present. Let's just test that function. So we're not doing anything with the web right now. I'm just calling get news with some sites and topics. It's the default site and topic. So I think it's Guardian and Tech. We get the articles by calling the function we've been using all along. And then we're going to call this display web and just see if it's doing the right thing. So we'll run it. And it's hard to tell whether it is or not because we're not browsers, we're people. But if you look at this carefully, you'll be able to see that it's, not sure why it's not scrolling. Okay. You will be able to see that it's actually correctly formed HTML. It's got these A tags that I mentioned. Here's an href equals, and that's the link to one of these articles, and it's followed by, can't really see it without scrolling over. It's followed by the article title. So this looks reasonable, but the proof is actually, how does it look when we run it, when we give that output to a web browser. So that's what we're going to do next. We're, once again, same code, but instead of the function that gets dispatched just doing something trivial like return hello students, it's going to return this display web, that's the function we just tested, of get news with the default sites and topics. Now this is a little bit of what we call function chaining, right? We're calling get news inside of a call to display web. And the way this works is inner to outer. So the get news function goes first, and whatever it returns is passed to the display web function. If that seems a little weird or uncomfortable, you can always say something like news equals, you can pull these apart like this. News equals get news, and then display web of news. And I hope that it's clear that I was just like nesting one function call inside another, but functionally it's the same thing as doing it in multiple steps. And maybe it's cleaner and easier to read in that way. But anyway, this calls display web with the articles it found. I should probably call that articles for consistency. And it returns this HTML, and that gets sent all the way back to the browser. So let's try that. I will run it. Once again, I get this special link I can click to get through, and it's way oversized, but it looks actually pretty good. Now this is very basic HTML, right? I mean, this looks like it came out of the 90s, but we can make it look nice and make the layout nice and all that kind of stuff. But really, I'm just after functionality at the moment. And let's just test this. Like the title here is New Zealand Stock Exchange hit by cyber attack. So if I click on that, let's see, it seems to take me to the right place. And in fact, one thing I don't like about that is, if you noticed, it replaced the tab with the link content. So it overwrote the tab I was on. And if I wanted to go back to my article list, I have to go back, click my back button. And that's something we can fix with HTML, and it's quite easy to do. I'm going to stop this server from running, and I'm going to change one little thing in the A tag, or the A element. HTML takes a special parameter called target equals, and you give it this name _blank. It's just one of these HTML trivia things that if you know it, it causes the A link to behave slightly differently. And I have to look it up half the time. So there's no real logic to that. It's just something you have to know or look up. But if I run this, it redefines the function. I'm not going to retest it. I'm pretty sure it's okay. And now I'm going to rerun the app, and I'll click on that link. It gives me to proxy into the web server, and there it is. And let me do Google to lease extra 70,000 square feet, and keep an eye on the tabs up here. And because I changed that target, it opened this up. It's the same article I was expecting to see, but it opened it up in a new tab. So when I'm done reading this, there's my original tab. So it just gives you the sense that, by changing your Python code on the server, you can change what HTML you feed to the client, to the user's computer, and in turn how the document ends up getting presented to them. Okay, so now I've got a version of this app that runs on the web, and I can use it to find out what's going on with the articles I'm interested in. It just died because I stopped running that server cell. But what I want to do is combine our config data with this web app. And that's actually really easy. All I have to do is say config data equals load config, this line right here on the cell below. And then the rest of the function is exactly the same. I've just reloaded that config data from disk. Now, if I run this cell, it's not going to do anything different because, actually, let me do it. Because I haven't changed the config data. So if I go here, you're going to see it's still, if I hover over this, I can see that's the Guardian. There's 46 hits, and all the way at the bottom is the Guardian. So it's still looking for only one site, the Guardian, and only one topic, tech. To force this to change so that I can prove it's actually loading my config data, I'm going to run this cell, which loads the config data, appends to, remember this config data is a dictionary. I use the sites key to reference the list of sites, and I append to that list washingtonpost.com. And then I do save config. Let's run that. And actually, just to test that, let's do x equals load. I'm being lazy with my variables because this is just a temporary cell, but I'll do x equals load config print x. And there it is. It's got, notice it's got the Guardian and the Washington Post. In fact, let's add an interest as well, or a topic as well. Config data topics append politics. Let's do this. And I did something wrong. This. By the way, this test here, I could have chained in a simpler way to do this. As we talked about, these nested function calls are just fine. And that gets me to just a nice little one-liner. Now you can see I have the Guardian and Washington Post twice because this was appending it twice, and both topics, tech and politics. So now my configuration is exactly what I want, except I have this duplicate Washington Post, which I really don't want. So I'm going to delete it, delete one occurrence of it. List object has no attribute delete. Okay, I think it's remove. And let's see how that looks now. Okay, now I have the Guardian, Washington Post, tech, and 2 politics. Okay, I might end up doing this all day. So what I'm going to do is use my reset config function so I don't waste too much time doing this. And I think this should do what I'm hoping. Let's see. That. Not subscriptable. Okay, let me try setting it to config init. Okay, there we go. Guardian, Washington Post, tech, and 2 politics. And I'm not going to worry about the 2 politics because I'm getting annoyed. But scene is still empty. Now let's run our web server with this. And let's go to the client. And we see we have more than those 40-something articles. We should also see that we have, starting at the top, we have Guardian articles. But if we scroll towards the bottom, we have Washington Post articles. So this is proving to us that our application is actually remembering the configuration and reacting to it, doing what we would hope it would do. The last step is to keep track of what we've seen, right? So I don't want to keep, every morning when I run this app, I don't want to see the same, although there'll be some new articles, of course, but I don't want to see the same articles I went through the day before. And here's how easy this is to do. We have the same app equals Flask startup. We have the same route for /. We have the same function definition. We have the same load the config. We have the same get news call. But now we have one addition right here. We're going to create a new list of articles, which we'll call filtered articles. And this is going to be all of the articles we got back, except for the ones we've seen already. Somehow we're going to remove those or not include those in the filtered article list. And here's how we do that. We start filtered articles to be empty, and we iterate over the articles. So for I in articles, this is what we just got back from Get News. We grab the ID, that's the URL of the article. And this is really can be thought of as a unique identifier for every article that doesn't change. So if we've ever seen it with that URL, that's the same article we're looking at here. And what we say is if ID not in config data seen, that sort of sounds in English like what the Python is doing. If that key is not in the seen dictionary, then this is a new article. And the first thing we want to do is mark it as seen. So we say config data of seen sub using key ID equals true. And now with this statement, we've just recorded the fact that this article has now been seen once. And we add it to the filtered article list. We do that for every article. We say if we've not seen it, add it to the seen list and add it to the filtered list. So we present it to the user. If we don't see it, or rather if this is false, if it's in the seen list, we just skip it. We don't want to do anything with it. When we're done iterating over all the articles, we do a save config. We return display web just like we did before, but it's display web on the filtered article. So we only show the new articles. I could call that new articles instead of filtered, but you get the idea. Anyway, let's run this one. This is our grand finale here. If I come in here, I get all the articles we just saw, right? Here's the Guardian stuff. Here's the Washington Post stuff, and there's 87 total articles. Now I'm just going to refresh. I'm not changing the notebook. I'm not changing the server, not touching anything on the server side. I'm just refreshing this page, and it says nothing new to show you because it recorded all of those URLs in that data structure. Now, what happens if I stop and restart this server? Can anyone guess before I actually go there what will happen? Will it show me everything or just the stuff that's new? I'll wait. No guesses? Is anybody still with me? What's going to happen is, because we're calling save config after we set up this scene dictionary, and if we look at save config, it is storing, where is it? It is storing the full data structure, which includes that sites guy, that sites dictionary. So if we add a code cell here and just look at what's in that saved config file, sorry, not text, that would be code. Let's do cat of mynewsfeed.config. CFAT. So I have to stop this first, and now I broke my rule that I wasn't going to restart it. What you see here is the sites and the topics, but here's all those scene references. So we saved all those things on disk. And the answer is that we will just, if it was running, I shouldn't have stopped it, but it will just, again, say there's nothing new, because it remembered by saving that information on disk what it has ever shown you in history. So it's now able to save configuration data and read it again. It's now able to filter out things you've not seen before. And it's now got a nice little baby web UI on top of it. And what we're going to do next week is try to do some AI in Python. We're going to do a little bit of rudimentary machine learning. And I'm going to try to figure out a way to use machine learning to improve the way we filter these, or the way we decide which of these articles is of interest to us. So rather than just say, give me anything with topic politics, I want it to somehow figure out, based on what you have shown that you like in the past, which articles will match your taste or your interest. So that's what we'll do next week. I think one thing I'll also try to do is show you how to run this program on the web. I mean, serve it kind of in the cloud, because right now, like, you can serve it from your notebook and you can serve it from your laptop. But if you wanted to like serve it to somebody who wasn't on your computer, or, you know, who was making like special arrangements, you'd like to know, how can I take a Python program like this and make it available for anybody to access on the web? And I'll show you how to, one way to do that. There are many ways. So a few homework problems here for you. The biggest theme here is I want you to take the code we wrote in this notebook and see if you can move it into the Mu environment or any other IDE that you might use, and see if you can get this code to work on a standalone basis outside of a notebook environment. And that really takes us to the end of today, and it's just 30 minutes after the hour, so I think it's a good time to stop. If you have questions, want to hang on, I'll be here for a few more minutes. Otherwise, thanks for coming, and hope you have a good week.
Thank you, Mark.
You're welcome, George.
Thank you, Mark. Goodbye.
Bye. You're welcome.
Thank you, Mark. Goodbye.
You're welcome. Bye.